Seaweed has been having a moment. Eco-influencers and columnists rave about its benefits in everything from beauty products to biofuels. But what do you do with a seaweed that is so toxic you can't even safely bury it in the ground?
So Paddy, I thought seaweed was cool.
Seaweed is really cool, but there's lots of different types of seaweed. There's about 11,000 different kinds that we've documented, and there are probably many more that we haven't. And they have loads of different properties. Some of them are useful for making plastic, some of them are make great moisturisers, some of them are really good for fertiliser. And the one that we're dealing with here, the sargassum, that has quite poisonous properties. It's absorbed lots of arsenic from the ocean water as it grows. And that's not necessarily a problem when it's out sort of mixing around in the ocean. But when it comes into the coasts in very large amounts, it can become really, really problematic.
The floating seaweed Sargassum is a useful part of its ecosystem, providing much needed shelter and breeding grounds for birds, fish, eels and sea turtles. But lately, vast rafts of it have been washing up along miles of Atlantic coastline in piles sometimes metres high, turning brown and fetid as it rots.
People, get ready for the smell tomorrow.
It's causing massive economic and environmental harm in communities from Ghana to Florida, but the worst hit is the Caribbean.
And why is it coming into the coast in large amounts?
Well, it's being swept around by the currents and the trade winds in the central Atlantic region. And as it gets swept towards river deltas, it uptakes loads of nutrients that are coming off of the rivers and explodes in terms of growth. And as it does that, it starts getting swept into the coasts and starts piling up in massive, massive amounts.
But this stuff's been around forever. You know, Columbus saw it, the Vikings saw it. Why is it a problem now?
The area we're talking about, the Great Atlantic Sargassum Belt, has only been happening since about 2011. So it's quite a new phenomenon. And it's quite distinct from the Sargo Sea, which is further north, which has been around since records began.
And is it true we can see this belt of seaweed from space?
Yeah, you absolutely can. You can track it on satellite, and it covers almost an area, not continuously, but the whole area is about the size of Brazil.
What, really? Why are we only hearing about this now?
Well, it has been occurring for quite some time, but people are starting to hear about it a lot more as it's affecting tourist areas, as it's coming further north and hitting the beaches in the US. And just the sheer amount of it is starting to really draw attention. It's been going on for about 10 years now, and no one has figured out a solution.
Sargassum tangles with fishing boats and water purification systems, releases harmful gases when it decays, and kills coastal seagrass and baby turtles. But the fact that it absorbs arsenic means it can't be used as a food for animals or humans without intensive processing. Even composting could introduce arsenic into the water table and compromise drinking water.
So what's the plan? What are you going to do about it?
So we think what we can do is kill two birds with one stone. So seaweed, all seaweeds, as they grow, photosynthesize. And that means that they can be really handy for carbon absorption. So we need to absorb a lot of carbon dioxide from the atmosphere, excess carbon dioxide that we've put up there. And what we think we can do is sink the sargassum into the deep ocean and remove that carbon that it contains from the fast carbon cycle.
How exactly are you going to sink it?
Well, we've invented a robot and is designed to intercept the sargassum mats before they come to the coasts and sink them into the deep ocean for carbon dioxide removal.
But this is a problem in the tropical belt of the Atlantic. Why are we standing in the snow in freezing Scotland near Glasgow?
If you want some great marine engineers, then Glasgow is a fantastic place to get them. Shall we go now?
I think we should.
Let's do it.
Paul Gray is head of engineering at Seaweed Generation, having left his previous job building military submarines.
And this is home base?
It is, yeah. Welcome here.
All right, thank you very much. I'll follow you.
Welcome inside.
Oh, thanks.
So, there we go.
Oh, so this is the beast. Paul, I have to confess it looks a bit more like a boat than a robot.
Yes, because fundamentally it's operating on the surface of the ocean, but it's still semi-autonomous at the minute, and as such classed as a robot.
It's going to be talking to you?
It'll be talking to us via a Starlink data link.
Starlink?
Yes, that's SpaceX live internet.
And it'll talk to you and you'll be able to talk to it?
Correct, yeah, and we'll have live video feeds We have telemetry systems. We get all the data from it constantly, basically.
I guess there's no secret then how you're going to power all that.
So we've got 1.6 kilowatts of solar panels on board on this small version, and that is enough to power the vessel indefinitely in good sunshine.
So this is the batteries here?
Correct. So that's in the red storage box here. I'll lift that up for you.
They just look like a car battery.
Correct. But these are lithium iron phosphate batteries.
So lithium iron phosphate. What's in our phone?
That's lithium ion,
Right.
which is a different chemistry.
Yeah.
And they're the ones that are a bit dangerous.
Oh, so you've got to make sure that these are very stable.
Yes, these are perfectly safe batteries.
Which you need because these are going to be out at sea on their own.
Yes, they've got a lifespan of at least 10 years, and that they'll still be at about 80% capacity after that.
I can't help thinking, there's only one of it.
So this is just the first one of many. It's often more efficient to have a swarm of vessels and they all operate collaboratively, and that enables you to be more reactive. We're developing swarm software that will enable them to operate in the most efficient way possible.
I thought when I was getting the research notes on this film that I was going to be looking at a submersible, but this is a surface vessel.
Yes, this is the first prototype, and we've got to prove the principle of it so that we get all the scientist community on board to ensure that we're not doing any damage, because we're doing something a little bit different. We don't want to be developing it for 5 years and it's too slow. We need to be quick and be a fast reacting company and develop things. There's a lot of other businesses looking at carbon capture, but we're delaying and we need to just get on with it.
Solar panels on a submersible, how does that work?
So solar panels can actually be more efficient, slightly under the water.
Oh, really?
The light refracts in, and it enables, by going to a submersible, it enables us to avoid issues with the weather, and which is a big issue, and it allows us to operate in all conditions. Even if a hurricane comes in, we can tell the vessel to go underwater and stay safe, whereas a surface vessel would have to go back to port and hide.
The swarm of robots will initially work on finding and capturing sargassum in the Caribbean, using a floating scoop which will be towed behind the robot to collect and then sink the seaweed.
This gets pulled through the water and the sargassum enters through here. Then it builds up until it's full, at which point the winch will allow it to drop, and that takes it down to the designated depth.
So you sink this box?
Correct, yeah. And there's little tiny air sacs on the sargassum, about the size of a pea. At the surface, the sargassum's still buoyant. As it sinks, it pivots downwards. This only goes down to 200 meters, and at that depth, the water pressure crushes the air sacs, at which point it becomes negatively buoyant. As it falls down to the designated depth, it will literally just fall out of the bottom.
Oh, I see, because this is tilted.
Correct, yeah.
That's very clever.
By using nature itself, the physics of the water column to compress it, that does all the work for us. All we've got to do essentially is transport it 200 meters down, and it does all the work for us.
Exactly how the cage will be floated and sunk to the correct depth is still a commercial secret.
Hello. Jeremy, is it?
Hi, yes.
I'm Neil. I couldn't help but notice on the back of your jacket there, you seem to have had a previous life.
Yes, last 15 years in nuclear decommissioning.
Really? So making sure that, you know, these old nuclear sites and submarines are safe?
Yes, yes.
How did you get from that to what some might think of as a madcap scheme here with this soon-to-be-able submersible robot?
Basically, this is exciting. It's innovative engineering and exciting. I've been in contact with Paul. He used to be one of my engineers, and what he was telling me was exciting stuff, and it's for a good purpose. The decommissioning side of things is good, you know, cleaning up a mess, but this is, I think, the way to go for the future of the planet, basically. So I made the jump.
But we've got this thing's maiden voyage today, if the weather holds.
Yes, yes.
And if it sinks, we're going to be looking at you, aren't we?
It won't sink.
So you're confident that we've got a good maiden voyage this afternoon?
Yes, yeah.
Great.
A couple of experienced engineers working on it. We're confident.
Nothing can go wrong.
Nothing could go wrong.
As a semi-autonomous vehicle, the final version of the robot will need to be smart and learn fast. It will also need to make a record of exactly how much seaweed it sinks.
That is one of the most salubrious offices I think I've been in a long time.
It's important to be lean in a startup.
All right, so yeah, startup, very much a startup. What do we got here?
So this is our deep sea observation pod. So we use this, there's a camera mounted on front.
Where's
and
the camera?
This is a camera.
Oh, I see, very
So
cool.
it can be controlled up and down, left and right. We can look around. And out here is a depth sensor,
Yes,
as well as a temperature and pressure sensor, so we can say how deep we are.
yeah,
And then this is a little computer that'll record all of that data.
right. And where's that going to be mounted?
So that'll be mounted right on the front. As it dives down to 200, 300 meters, we'll be able to see what's going on and record all of that and make sure that we're at the proper depth so that we know that the seaweed is making it down as far as it's supposed to be.
So this is to say each time we were able to empty this properly and we saw it fall.
That's right. This is our evidence. What we want to do is make sure that people trust us. We're going to put it online. We're going to make sure that we can see every dump, as well as it's going to return data that we can use to train for controlling our autonomous systems, because as of right now, it's dumb. We need to teach it how to behave. It can't become autonomous until we gather data.
Radio waves don't travel underwater. Does it surface and then bounce its...
Yes, designing that connectivity is part of my job. So this will connect via basically a network connection back to the boat, which will have the connection to the satellite.
So it's going to record everything, store it, come up, tell the boat everything it's seen, and that's going to load it up so you guys can know what's
That's
going
right.
on. And how far away is this from being ready to rock and roll?
This is ready to go. I've been developing this for a little while now, and all these wires, they're in the proper place and it's ready to get put together.
I guess it's going to be in a beautiful case when it's all finished.
That's right, yeah, this wouldn't survive long deep in the ocean, but we have a nice 200 or 300 meter rated ocean-proof, watertight case that this goes into.
What were you doing before this?
I've worked at a lot of startups doing a couple different things. I worked in healthcare, finance, and Patty came and said, "Do you want to work on saving the world?" And I said, "Of course."
That's quite a good sales pitch, isn't it?
It is, yeah, it worked on me.
Does it feel like that you're working on something that's...
It feels important, and everyone I tell, they're excited for us that we're working on this. I haven't encountered a lot of skepticism, which is different in startup land. A lot of people are skeptical about what you're working on, but when it comes to climate change and carbon dioxide removal, they just want to see it work.
So I'm going to ask you this question. I don't want the political or the investor answer. I want the personal answer. Do you think this is really going to work?
I think so. We have the scientists that have convinced me that it's going to work.
And to begin that process, the prototype needs to brave the icy waters of a Scottish loch. The Seaweed generation team are out in force for the Algaray's maiden voyage.
Are you nervous?
No, excited.
Yeah?
Uncomfortably excited.
That's good, uncomfortably excited. In the long term, how does the company keep itself alive? How does it make money?
We are going to sell carbon dioxide removal credit, and that's part of the projected need for 10 billion tonnes of carbon dioxide a year that the IPCC has projected we'll need to rebalance the climate to stay below 1.5 degrees of warming. So companies mostly and individuals who are looking to get to net zero are they're stopping emissions as much as they can, but some of the emissions they won't be able to stop, and for that they will purchase credits.
So I'm a big company. I've got some carbon I can't get rid of.
Yep.
I could buy credits off you and have the Sargassum same.
Yeah, exactly. Yeah, so if you wanted to, say, fly from London to New York, we could offset that in about an hour.
And that's why the camera that Dan showed me is so important.
Yeah.
Because you're keeping a record of every load you sink.
Yeah, exactly.
It's crunch time. The Algaray is about to get her hulls wet.
Keep going.
With a tweak to the autonomous control system, she's off.
So far, so good.
Yeah, that's great.
Anyone who's ever launched a boat for the first time is always a bit worried, so I think everybody just wants to see how it's going to go at this stage. But once again, this is a prototype to test the scoop technology. It's not what the final design will be, which will be a submersible. So hopefully today, this won't be a submersible. I'm still having trouble seeing it as a submarine.
Startup company Seaweed Generation believe they can marry two crises to find a solution to climate change by sinking the excess of seaweed sargassum currently washing up onto Atlantic beaches into the deep ocean. So how much sargassum is actually out there? Well, there's someone who can tell us because amazingly enough, he's been watching it from space. Professor Chien-Man Hu runs the Optical Oceanography Lab, which pioneered the use of optics and satellites to study the ocean. In 2005, along with Jim Gower and Stephanie King, he used NASA's satellite VSAT to identify extensive lines of floating sargassum in the Gulf of Mexico.
Some plants reflect more in one color, other plants reflect more in other colors. So sargassum has a unique spectral shape. We look at the satellite images, we think these are sargassum rafts, large mats on the ocean. Then we validate what we see using field measurements. You can see the texture, you can see the morphology of every sargassum mat. Without going to the field, you know, okay, that is sargassum.
So when did you become aware of sargassum as a problem?
2011 was the first year that the Caribbean Sea had a lot of sargassum, but in the past 5-7 years, it became worse. And it became a new normal. Every year, about the same time, the ocean is occupied by the sargassum mats here and there. They're scattered around.
Is it always the same amount or does it vary?
It varies a lot from year to year. But as I said, in general, in the past 5-7 years, we had way more sargassum in the Caribbean Sea than before.
Dr. Hu's lab has watched sargassum explode since 2011, peaking at around 24 million tonnes last year, stretched from the Gulf of Mexico to the mouth of the Congo. But surely it's a natural part of the ocean. How has it become a problem?
It is indeed a critical habitat for many marine animals, fish, turtle, crab, shrimps, many things. So it's a good thing. But when you have too much of a good thing, it becomes bad. If you have too much sargassum accumulating in coastal waters or on your beaches, then it became very bad for many things.
So it's brilliant that you can view sargassum from space, but how's that useful?
The timely knowledge of sargassum amount and the location is critical in helping people to make decisions. The knowledge of the sargassum amount and the location is very useful in helping understand why in certain years we have more and in other years we have less. Can we predict, can we forecast using other information? So this type of retrospective analysis relies on historical data. So in that regard, the information is also important.
Do you think that climate change is one of the causes?
Well, climate change can result in extreme events, very strong wind, storm, and ocean circulation. So there is a hypothesis to speculate. In 2010, there's a stronger than usual wind and ocean crust to bring sargassum from the Sargasso Sea in the north to the tropical Atlantic in the south. And then they started to grow every year. In some years, we have stronger upwelling to bring nutrients from the bottom of the ocean. We may have more dust deposition events. We may have more river flows to carry more nutrients. So there are different factors. I cannot narrow down into a single one because the ocean is connected. But overall, as human beings, we should care about this emerging phenomenon.
And what do you think of companies such as Seaweed Generation that are using sargassum to sequester carbon?
Even if this strategy works, the total amount of the sequestered carbon is not comparable to the total amount sequestered by phytoplankton, by those little algae, simply because sargassum only occupies a certain portion of the ocean. But the ocean has this micro algae or phytoplankton everywhere. It's just a scale, matter of scale. But even one drop of a bucket is still one drop. If you keep adding one drop another, sooner or later you will have many drops to make a big impact.
Back on our cold Scottish loch, the alga ray glides across the water. Well, like a boat.
So it works.
Thank God.
Mike Allen is the Chief Science Officer at Seaweed Generation and an expert on all things microbial.
But there's hundreds of millions of tons, I guess, of this stuff across the Atlantic in this Sargassum belt.
Yeah, the Great Atlantic Sargassum Belt. So you're looking at tens of millions of tons of standing stock. But when it's out at sea, it's absolutely fine. It's absolutely fine. It doesn't do anyone any harm. The problem is it comes coastal, it comes into shallower water, and it blocks up, it gets really dense and thick, and that's when you get sort of ecosystem breakdown.
But you're going to take this stuff, tons and tons of it,
Yeah.
and drop it into the ocean. I did a master's in environmental science years ago, but the first thing they said was, always be aware of unintended consequences. You're going to mess with the ecosystems on the bottom of the ocean, aren't you?
We are, but not in that way. So when the seaweed comes up to the coast, it's very, very densely packed. We're not doing that. We're taking the seaweed when it's out at sea. It's not so dense, and we're spreading it over a large area, so it's not compacted. So I think we've run the calculations for our test site, which we have dedicated zones where we're sinking. We're looking at putting seaweed down there at around 10 grams per metre square at most, which is hardly anything. It's like 2 teaspoons of sugar, really.
And what will happen to that, the 10 grams?
That'll get remineralised, the bacteria will degrade it, or it'll get sedimented. So if it's remineralised by the bacteria, you're looking at thousands of years of removal from the carbon cycle. If it's sedimented, you're looking at millions of years.
Opinion differs on exactly how long this carbon will stay locked away, and of course there's need for far more research on the subject. But Mike Allen is pretty sure they're onto a winner.
But the key is that what you sink disperses as it sinks.
Yeah.
So it's not falling in great lumps.
It's not big clumps or bales or chunks. It's just dispersing naturally, as seaweed should do in the natural environment. We're just accelerating that process.
Seaweed Generation aren't the only ones working on sinking sargassum. Some are also doing it for carbon capture, others just to keep the beaches clean. But not all seaweed sinking is created equal. When sargassum is sunk in shallow waters, it's likely to biodegrade and release carbon dioxide, or worse, a more potent greenhouse gas, methane. The alga ray is designed to sink sargassum only in extremely deep water.
So the ocean is a massive carbon sink. It's bigger than anything else on Earth. So 37 trillion tons of carbon are in the ocean. So if you compare that with the terrestrial environment, you're looking at about 2.5 trillion tons. The atmosphere is about 900 million, and the surface ocean is similar, around 900 million. So there's about 16 times more carbon in the deep ocean than there is anywhere else on Earth. So once you're adding carbon into that amount, it's actually a tiny fraction of the amount that's already there. So there will be perturbations, but it'd be much smaller than anywhere else where you can put the carbon.
But I thought the ocean was getting saturated with carbon now.
Yeah, the surface is. But of course, the surface is so far from the deep ocean, they're very, very distinct. So the surface is like the fast carbon cycle. Everything's cycling, there's loads of energy in it because you've got the sun driving it. But in the deep, deep ocean, it's slow, it's steady, it's under pressure, it's dark, it's just cold and a lot slower. So once you put carbon into there, it's just taking it away. And that's what we need to fight climate crisis.
In order to sequester enough carbon to stay below even a 2-degree rise in temperature, we need to remove billions of tons of carbon annually. This project was never designed to be all of the solution, just one part of it.
Would you like a go?
I'm not very good at joysticks, but I'll have a go. I'll have a go.
So if you just left and right is that one.
That's turning.
Go. Yeah.
And that's forward and back.
Correct. Yeah.
Right. Oh, going a bit fast. So this view I've got here, you'll have a similar view when they're out in the ocean.
Correct. Yeah. So we'll be live stream this via the satellite data link.
So you'll be able to tell what they're up to.
Yep. And we'll monitor for other craft in the area, any animals and things like that.
Exactly. You'll be able to say, get out of the way of that, that killer whale.
Yeah.
Or that oil tanker.
Yes.
It's hard to tell from meeting the Seaweed Generation team if they're a tech company led by profits or a bunch of dreamers hoping to save the world. Maybe they're both, but one thing is sure, they're gambling their own futures on trying to make a difference.
Paul, will you be going out into the Atlantic as well?
I'm going to try and cross it in this.
Wait till it gets wavy.
I have to say, you know, we guys seem to be having a bit too much fun
Oh,
for
yes,
a
sorry,
great
yeah.
environmental startup
Well-
that's about to save the world.
I think having fun's important, otherwise we'll give up, won't we?
There's not going to be just one solution, is it?
No, there's going to be a whole raft of them. This is just a tiny part in a big machine of the changes that humans as a whole need to make.
You guys have all had previous jobs, you've been a nuclear engineer, but you've all given up those lives, those jobs, and you've taken a punt on this.
Yeah, I think it's really important we all make a change and do the best things we can. If we don't start making an effort to combat climate change, we're all doomed. And frankly, I'd like to leave something for my kids. I don't want to leave a barren world for them. I got on all right, now I'm thinking how to get off. Thank you.
And let's not do that again.
Well, congratulations. So that's a proof of at least one concept.
Yeah, that's the first part. And then the second one is we'll start testing the scoop next week.
Here or in the sea?
In the sea, over in the Gairloch in Scotland.
Yeah.
And then hopefully invite you back at some point. Yeah,
Yeah,
really
yeah.
good.
We definitely want to come back when it's really a submarine.